Section 2.2 could almost be just an extension of 2.1. It has a different name, but to be honest, it's really not a different kind of material. So this section starts out, and it has the title, The Derivative. And the first thing we're going to encounter is two different definitions. So this is the definition of a derivative. For those of you who've had calculus before, you know where we're headed very, very soon, but we aren't there yet. So please bear with us while we're still working through the preliminary pieces of the derivative definition, okay? So this says the derivative of a function of f at the point x equals a is defined as f prime of a equals this. And where have you seen this before? We had two different things we saw it in. What were they? Slope of a tangent line and velocity, right? Instantaneous velocity. So this is our third name for the same thing. We now have three names for the same quantity. We have slope of a tangent line, we have instantaneous velocity, and we have derivative. I'm sure you don't have three names for anything else in your life, do you? We actually do that in English at least quite a lot, where we have three names for the same thing or something, right? This works provided the limit exists, and we use the phrase or the word differentiable to mean that it works. If it has a derivative, we say it is differentiable. So those two words are sort of synonymous. Okay. Now there's an alternate definition. Has everybody gotten this one pretty well filled in on the notes? If you don't have notes printed out, you can fill those in afterwards. They are out online. Alternate definition of the derivative says the following. The derivative of the function is the function f prime. And I didn't notate that very clearly on the other one, but we have this notation with this sort of a prime notation. F prime of x is the limit as h approaches 0, and it's the same thing. Look carefully, what's different between this one and the last one? Has an x, and the last one had an a. This is a very minor detail. It's really not that important. But it's how they're describing it. Over here, they're saying the limit exists at a point, A. This one's saying the limit exists everywhere that A will work. This derivative will exist at all of the A's that work. This definition holds. The process for finding a derivative is called differentiation. We say f is differentiable on the interval I. This is an I. I know it almost looks like a 1 or something. It's actually the letter I, capital I. And it's differentiable on the interval I if it's differentiable at every point on the interval. And if you'll remember, in the last section, we actually talked about where slopes didn't exist. Remember, those tangent lines didn't exist? We had three issues. Do you remember what they were? Discontinuities, sharp turns, and vertical tangent lines, right? So we are going to have those things not happen in order for this definition to work. We have to have things continuous, so there can't be any of those discontinuities, jumps, holes, or asymptotes. We can't have things not smooth. They must be smooth, no sharp turns. And we aren't allowed to have vertical asymptotes. If we have any of those things happen, it would not be differentiable at that point. So we're going to do this again. This question is asking you for the exact same thing that we did two examples of in the last section. It says it in a different way, however. It says, compute the derivative function f prime. Okay? That is exactly asking you to do that limit with the f of x plus h minus the f of x over h. It's the same thing asked in a different way. But we're going to do it in general with the x plugged in. So we're going to find f prime of x. And our definition says that the way that we do that is that we find the limit as h goes to 0 of f of x plus h. And if you want to put the x as an a, you could do that. Minus the f of x over h. In that numerator, you already know one of those pieces. Which piece do you know? We know f of x. It was given to us, right? How in the world do we write out what is f of x plus h?
plug x plus h for x.
You guys are getting it now, right? You plug the x plus h in for every x. Now this one's different than the other section though, because I actually have two locations where I have an x, don't I? So I got to replace them both. So I've got the x plus h that should be cubed, and then I have 2 times the x plus h plus the value 1. And I'm supposed to subtract off, and I've run out of space, I'm supposed to subtract off the original function that I was given, f of x. So that's x cubed plus 2x plus 1. I'll try and move this over and see if I can give myself a little bit more space. Just by the skin of our teeth, I could squeeze it in, right? All right, so we're going to simplify the numerator, right? Okay, just like on the last one, or it was the first one actually that we did in the last section, we can't just distribute the cubed. It's this x plus h cubed is not x cubed plus h cubed. All right? I'm going to jump to the end of the sort of fun, exciting example of what this is. If you don't remember how to do that, you're just going to multiply it out by itself 3 times. But if you do that, you end up finding that it's x cubed plus 3xh squared. Well, I'll put the x squared first. X squared h plus 3xh squared. It doesn't really matter, but I will. Plus the value h cubed at the end. I'm going to distribute that 2 through the x plus h. That's 2x plus 2h. And then I can distribute the negative through the x cubed plus 2x plus 1 to give me negative x cubed, negative 2x, and negative 1. Oh, I left off the plus 1, didn't I? Nobody wanted to tell me. Sorry, this 1 right here I left out. There's that plus 1 over h. So this piece came from here. This piece came from here. And then the last piece came from here. Okay. All right, so what simplifies? What do you see? X cubes go away.
2x.
The negative 2x and the positive 2x go away, and the 1. And if we didn't make a mistake, everything on top should have an h in it. Does it? Excellent. So I'm going to factor that h out. So this is the limit as h goes to 0. And take the h out. It's going to leave me with 3x squared on top, or inside, minus the 3xh plus, sorry, not minus 3xh, plus 3xh. And then plus h squared plus 2 from that 2h. All of that is divided by h. Now what? The h's do cancel. So I now have the limit as h approaches 0 of 3x squared plus 3xh plus h squared plus 2. Can I plug in 0 for h? I can, and what will I get? Plus 2. And that is the f prime of x that we were looking for. That's the formula for the derivative. All right. I'm going to stop there for today.